So, welcome to the video lecture series on formal languages and automata theory subject. In today's lecture, we'll be learning about a post-correspondence problem. So, what is this post-correspondence problem? Generally, when a Turing machine is concerned, we have two different problems. One is called as a decidable and undecidable problems. And this post-correspondence problem pertains to undecidable problems. That means you are supposed to find a solution. Multiple solutions will be there. In some cases you can get a solution. In other cases, if you put some other options, you won't get a solution. So such kind of problems are called as undesirable. So always you won't get a solution. Okay, depending upon the options, you sometimes you will get a solution or sometimes you won't get a solution. So such kind of problem is called as post correspondence problem. So we'll learn about post correspondence problem today. Now, the classic example for post-correspondence problem is a very prominent and significant example is using a set of dominoes here. Dominoes is actually will be having a numerator and denominator where you can arrange this dominoes in any order, but the constraint is when you arrange these dominoes, the numerator and denominator should have the same string. The string should be equal. Numerator string and the denominator string both should be equal. Whereas you are supposed to arrange these dominoes in an order where both the numerator and denominator strings are equal. So we have four different dominoes where in the numerator, in the first domino you have B, and in the denominator you have CA. And in the second domino you have A on the numerator and AB on the denominator, so on and so forth. But the constraint is, the condition is, you can use this dominoes any number of times, but finally you have to make the numerator string and the denominator string equal. So that's the scenario here. And now you can see here that, so how to select the first domino? When you select the first domino, see here, in the numerator and the denominator should have identical character. So if you take up the first domino, B and CA, B is the first character and CA is the first character in the denominator, and there is not any match here. But when you come for second domino, A is the first character in the numerator and A is the first character in the denominator. Obviously there is a match. Since there is a match, you can use this second domino as the first arrangement here. So when you arrange it, I'm just putting A and AB here. Now what happens here is numerator and denominator A and A matches, but in denominator you have a B now. Okay, but there is no match for B on the numerator. So what you have to do is you have to select a domino where B is the first character, where in numerator part you should have B. Okay, if you just look into that, you can see only the first domino falls under this category, B and CA. Okay, B is the first character. So you want to find the match for the denominator B. So numerator there should be a B, then only there will be a match. Okay, so when you select it, now B and CA. Okay, and B cancels now. Okay, in the numerator now you have AB, and the denominator you have AB and CA. So now CA is the excess here. So CA is actually available in the denominator. Now you have to find a domino where numerator is having a CA. So if you just check it out, CA numerator in the third domino you have CA on the numerator. So you select the third domino now. So when you select third domino CA, now CA and CA matches here, but you will have one excess A at the bottom of denominator. So in denominator you have one A. Okay, so you need a on the numerator. Okay, so you should find a for numerator here. So when you there are two possible matches. When you use second domino, A is on the top, and again you will get AB on the bottom. So now either you can use select domino 2 or domino 4 here. Okay, now when I select domino 2, now A and A matches here. Okay, and additionally you have AB on the denominator. When you have AB on the denominator, obviously in the numerator you should have AB. Okay, so which on your domino is having AB on the numerator here. So we can see that domino number 4 is having AB on the numerator, isn't it? So when you select A, B, C and C, Now obviously A and B, AB matches and C matches. Now you can see that the numerator and denominator have equal amount of string. Obviously there is a match. Okay, now we will just put the numerator strings one by one, or domino wise. So first numerator A is there, and second numerator B is there. Third again you have CA. Fourth you have A, and fifth you have ABC. So this is the order which we have arranged. Now we will go for the denominator. Denominator first you have AB, second you have CA, third you have A, and fourth you have AB, and fifth you have C. Now when you just check it out, the numerator and denominator matches with each other. So this is one of the problems which pertains to post correspondence problem. So classic domino example. Now we'll go for another problem here. Now this is another way of doing the same problem. For example, in the previous case, we have B is the equation model A by AB. Okay. So now the same problem can be represented in a different way like this. So here what we have done is, this is another form of representation of a domino sphere. So A actually points to numerator and B actually points to denominator. Okay. So the first domino having 1 on numerator and triple 1 on the denominator. The second domino is having 1 0, triple 1 on the numerator and 1 0 on the denominator. And the third domino is having 1 0 on the numerator and 0 on the denominator. Okay. Now we will find a match here. Which domino we have to select first? Okay. So domino 1 and numerator 1 and denominator 1 matches here. Obviously you can select domino 1 or domino 2. In domino 2 actually two characters matches with each other. Numerator 1 0 matches and denominator also 1 0 matches. Okay, so I am selecting domino number 2. So select domino number 2. When domino 2 is selected, so in the numerator it goes 1 0 1 1 1, triple 1 goes here, and in the denominator 1 0 goes here. Now 1 0 and 1 0 matches. Now you have 3 1s excess on the numerator. So you should select a domino where 3 1s are coming in the denominator. So obviously now we will select domino number 1 here. So when we select domino number 1, so 1 actually goes on the numerator and 3 1s actually comes on the denominator. Okay. Now when you just compare these two strings, you can see that 1 is actually excess in the numerator. Okay. So now you have to find a 1 in the denominator. So obviously when you want to find 1 in the denominator, again you can select either domino number 2 or domino number 1. Okay. So because both has 1 as the first character in the denominator, isn't it? So I am selecting domino number 1 again. So when I select 1 on the domino number 1, now triple 1 goes here. Now obviously now what happens here is, when you just make a close match, you will see that 1 is actually excess in the denominator. 1 is actually excess in the denominator. So now what you have to do is, you have to select 1 in the numerator. So now when you want to select 1 in the numerator, obviously there are 3 options, 1, 2 and 3. But I am selecting 3 here. When I supply 1 domino number 3, now when I select domino number 3, then 1 0 goes on the top, 1 and 1 cancels, you have 0 excess. Now when you just apply the denominator, 0 applies here. So now when you just make a close comparison, there is numerator and denominator matches with each other. So this kind of problems are called as post correspondence problem. So you will use multiple dominoes to match a string on the numerator and denominator. So thanks for watching the video. Have a good day. This is Dr. K.N.Sivabalan.